Just a quick note for all animation videos that you're going to be watching is that the software that captures the video actually captures at a frame rate of 10 frames per second. So it's going to look choppy no matter what in these videos, but once you actually run it in your program, you're going to find that things move a lot smoother and cleaner. Thanks for listening. So the problem we presented in the last video is what if, even if we're moving at the slowest pace possible, 1 pixel per update, that's still 60 pixels in a second. That may be too much for whatever it is you're doing, depending on what game you're making. Maybe you're trying to make a snail move across the screen or something like that, which you may want to move 10 pixels in a second as opposed to 60 pixels in a second. That's just not possible because we're adding on whole numbers. Well, the solution to this is to change x speed and y speed to floats. Float x speed and float y speed. So let's say we want to move, instead of by 1, let's say we only want to move by 0.5 f. And maybe this is 1.5 f. Well, negative 1.5 f. And that's fine. But what we need to do is a little bit more than that still. Now we need to actually track where we currently are. So the problem is that because our rectangles can only handle integers, it's not going to be accurate enough to get what we actually need. So basically, we're going to need a second set of data. So what we're going to use is we're going to use a new data type called a vector2f. Vector2f is just a float coordinate, an x and y coordinate. So it's an object that can hold both an x and a y simultaneously. So we're going to call this mush position, mush pos. We're going to say equals new vector2f. And for now, we're just going to set that its x coordinate is 0f and its y coordinate is 0f. We're going to change this in a second. We're going to go down and change it in load content after we set up the dest rec, because we want it to be technically at the same location as the destination rectangle at the very beginning. So our mush pos is going to be, our mush pos.x is going to be equal to our mush image.destrec.x, and same for our y. So now at the very beginning of the program, the mush position x and y are actually the exact same values as the destrec. So the only other change we need to make is down here. So instead of modifying destrec directly with our speed, we're going to modify the mush pos variable, the mush position variable, because that one can handle float values. So I'll describe how this is going to work in just 1 second. Let's just quickly write this out. So mush position.x is going to be equal to mush position.x plus x speed. So it can handle that float value. Similarly speaking, I do the same thing for y. And then we're just going to change the y values, the y speed. And then down here we can say .destrec is equal to mush position.x. And that's great, except that's the wrong data type. This is a float, and this is an int. So we need to tell the float to stop acting like a float and start acting like an int. And we can do that by casting it to an int. Now what's going to happen is any decimal places on there are basically going to get taken away. They're not going to exist anymore. So let's say, for example, we started at 100 and our x value is 0.5. That means after one update, mush position.x is going to equal to 100.5. Well, if we cast that to an integer, the 0.5 goes away, which means the destrec.x is not going to get 100.5, it's going to get 100 still. The next time through update, mush position.x is going to be 100.5 plus another 0.5, which gives it 101. So then when it casts it to an integer, it's still 101. So what that basically means is that that the position stayed in the same spot for 2 frames, 2 updates. So what is going to happen is it's actually going to move at half the minimum pace, because it's staying at the same spot for 2 updates. Similarly speaking, if I put the X speed at 0.3, then it would stay at that frame for 3 updates, because 0.3 is roughly a third of 1 pixel. So it's going to stay at the same place for 3 updates. So it's going to move a little bit slower. So you're going to see it kind of creep along. So for now, let's just add this in. Now we're adding on the Y speed, but we haven't actually added it to the desdirect.y. So we'll go down here and we'll add on the Y, same idea. But I don't actually want it moving in the Y direction right now, so I'm just going to set the Y speed to 0. So now when we run it, we see it moving at a much, much slower rate. Put, 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 put. And we can slow it down even further just by changing our X speed. Let's put that at 0.3. And it's moving even slower now. Let's move it at 3 pixels. And woof, there it goes across the screen. So just by changing our variables now, we can easily affect the outcome. So what we need to realize is that when we're adding our X speed and Y speed, we're not actually adding it directly into the destination rectangle anymore. We're adding it to some kind of temporary placeholders. And these temporary placeholders can handle the decimals. Then these temporary placeholders are going to be converted to an integer to cut off the decimal, and then store that value in the destination rectangle. This is going to allow us to basically duplicate locations in multiple updates to make it seem like it's moving slower. But because it's only 1 pixel, our eyes aren't really going to pick it up that well unless it's staying on there for a long, long time. So for example, if we set this speed at, say, 0.01, you're going to see it look a little staggered. Put, 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 put. Barely even moving. You can kind of see it trickle across. So that's obviously way, 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 way too slow. That means it's going to take 100 updates for it to move 1 pixel. That's quite a bit. Too much, in fact. So that's how we handle basic translation. So we can slow it down or speed it up however we see fit. Now, we can start moving things translation to different keys and stuff like that, but what we're going to do, we'll handle that in the input code so you can see that in a little bit more clear state. That's it for translation.